Today we are gonna have several speakers from, very popular tools in HPC world. So let me give you a very quick introduction of this session, and then we'll just start 7 very interesting tools talk. Okay. So what is your probably you take time? Yep. Okay, so what is your favorite? Printf, okay. Same, right? So when I was a student, I wrote my code in my laptop or workstation. So at that time, print statement was one of the most efficient debugger, I thought. But HPC world, the situation is more complicated, right? So if you're running your application with a lot of compute node, there is some delay to get the printf statement, right? So you may not get the correct result from the print statement, or sometimes you may need to see more information, right? More in-depth information. So for this case, you can use a better debugger on HPC environment. So we are going to have several debuggers, which is popular on the HPC environment. So you can at least try, and then you may pick one of them for your application, okay? And how do you measure your performance of your application? Do you have any favorite way? Yeah, maybe just checking time, right? So you may just check your watch and then the measure time, right? So that could be the easiest way to measure your application performance, and then you can easily compare that, right? So you may run it on this computer, and then you may run it this computer, and then you can say, oh, this computer I got 2x speed up, right? But the problem is speed up is always better, good to have, but you still don't know how much headroom for your application performance, right? So you may get 10x speed up from this computer to this computer, but you may still use just 0.1% of the performance of that specific system, right? To know, you may need to use some flop rate or bandwidth or something like that, right? So if you measure the flop rate, every system has its theoretical peak flop rate, right? For example, next speaker will talk about A100 NVIDIA. So A100 GPU. If you use double precision FMA units, you cannot go beyond the 10 teraflop per second, right? So if your colleagues say, oh, I got 100 flop per second in double precision A100, you can know, oh, something going wrong over there, right? So because it's the theoretical peak is the 10 teraflop per second, right? Or maybe your code is memory bandwidth bound kernel, and then A100 case again, its maximum memory bandwidth could be 1.5 terabyte per second, or depending on the variant, it can be 2 terabyte per second. You cannot go 100 terabyte per second in single A100 GPU, right? So this kind of number, theoretical peak, give you what could be your maximum performance you can gain, right? Depending on the characteristic of your code, right? So if you know those information, you can easily check what is your efficiency in terms of the flop rate or memory bandwidth or something else. And then you may think, oh, I got 80% efficiency, so I'm fine with that. And you may say, even though I got 100x speed up in this system, still my efficiency is 0.1%. So there are something else I can do, right? So you can decide your decision, right? You can make your decision based on this number, right? So and another thing is, I just talk about flop rate and bandwidth, but there are many other components can create the performance bottleneck, right? So maybe your performance bound by the atomic operation of the architecture, or maybe some network bandwidth, and etc. Right? So there are many components. So to know this kind of information, you had better use leading profiling tool, which is optimal for HPC environment. So during today's session, you're going to have at least 5 or 6 profiling tools to check how much performance you get from that specific system, right? So in this track, we are going to have 7 very powerful and very popular tool in HPC environment. it's not very easy. So each tool has their own characteristic, and for each tool, you may need to spend several days to understand all the features. But today, we just want to give you very introductory information of each tool. So once you're back, and when you need the tool, maybe based on this tools track, you may think, oh, maybe at this time I want to use this tool because of this reason, right? So we just want to give that information. So first set of tool is hardware vendors tools, right? So today we are going to have AMD, Intel, and NVIDIA speakers, representative. So they will talk about their popular tools. So you can get what kind of information. So you cannot expect you can use Intel tool on NVIDIA system, maybe later, but not the moment. So depending on the vendors, they have some different tools and characteristics, so you can check it. So Intel VTune Advisor, and NVIDIA Inside System and Compute, and AMD Argonne Profiler. So next set of tool is a cross-platform tool. So we have ARM Forge for DDT, for debugger, and Map for the profiler. So this is from ARM, but you can use this tool for other system, Intel system, NVIDIA system, AMD system, right? This is kind of a cross-platform tool. And another debugger, popular debugger, is Purpose Total View. So with this debugger, you can use different multiple systems, right? The last one is open source community tool. They are also a cross-platform tool, but they are from the university. So Rice University provides HPC toolkit, which is very powerful. And Tau is provided by University of Oregon. So these tools are community tools. So you can install those tools without license on your laptop, I think, right? John? Okay. So yeah, me and Scott are just the organizer of this track. So we are very happy to have 7 representative for tools. So Kevin for Intel, Chris for NVIDIA, and Suyash for AMD, and View for ARM, and Nikolai for Purpose, and John for HPC Toolkit, and Samir for Tau profiler. Okay. So this is agenda for today. So you can check this schedule at the ATPESC webpage. So in the morning, we are going to have a hardware vendor tool session. So Chris will talk about NVIDIA tool for 40 minutes after my talk. And then Kevin will talk about Intel tools. And after that, we are going to have the break. And then Suyash will talk about AMD. After that, at 11:10, we will have the parallel session. Okay. So after checking every things from lecture, you can decide. You can choose one of the rooms, this main room or a breakout room across the hallway. Okay. So during the hands-on, this is very interactive session, so you can freely talk about and ask some question, right? And then you can move around. Okay. So you may join the NVIDIA session first, and then you can come back to main room to attend the Intel or AMD hands-on session. Okay. After lunch break, we are going to have, we will continue 15 minutes for hands-on, and then 1:30, we will have the second session, cross-platform tool session. So ARM tool and 1:30, and total view at 2 to 10 p.m. Okay. And after that, again, we are going to have another parallel session. At the main room, we are going to have hands-on session for total view, and the breakout room, we are going to have ARM tool hands-on session for 1 hour. And then we are going to have a 20-minute break. After that, we will have open source community tool session, HPC toolkit talk first, and then Tau talk second, and then we will have the parallel session again. So Tau at this room and HPC toolkit at the breakout room. And then we will have the dinner and after dinner talk. After that, our speakers will stay at this room or another room, and then you can ask some additional question for last 75 minutes. This is optional session, so if you're so tired, you can take rest, or you can stay here and then you can keep asking questions, okay? And this is the systems for hands-on. So we have a fader, so you can check show rest, and then you can use specific tool. And then you may use NVIDIA Cloud GPU resource. So I think Chris will share the more information. And Intel Dev Cloud may be used for the Intel GPU. And AMD, the Accelerator Cloud, we have very limited resource because they are actually moving their system to different locations. So we have very limited resource. But if you want to use the AAC, just make your account and let me know, okay? So they need some internal approval process, so I need to ask them to approve your account creation, okay? So, and as Ascent, we don't have reservation, but you can use with the default queue with this project, okay? So I hope you guys will enjoy and this talk.